Good morning, students. Let us see how to design a full subtractor circuit. The first function of a full subtractor circuit is used to subtract three single bit numbers. So full subtractor can perform x minus y minus z, subtraction of three single bit numbers. That is the job of full subtractor. The objective of the question is to design a full subtractor circuit. So first you need to write the problem statement to perform the subtraction of three single bit numbers. Identify three inputs. The three inputs are x, y and z. So operation is x minus y minus z. What is the output you get for a subtraction? A difference and a borrow. So you know there are three inputs and two outputs. So draw the block diagram for it. So how many inputs? X, y, z. How many outputs? Two outputs. One is difference, other one is borrow. FS stands for full subtractor. So this is a block diagram for full subtractor question. And what is the third step? Drawing the truth table. So how will I design a truth table? I have three inputs, two outputs. So X, Y, Z are the three inputs, two outputs, B and D. So since there are three inputs, I get 8 combinations 0, 0, 0, 0, 0, 1, 0, 1, 0 till 1, 1, 1. Now what is my objective is I need to subtract x minus y. The result I need to subtract with z. So x minus y minus z. And write what is the difference value I get and what is the borrow value I get. So x minus y minus z. 0 minus 0 minus 0 is always 0 and there will not be any borrow, so 0. Suppose you want to do 0 minus 0 minus 1. Can you see 0 minus 0, x minus y is 0. 0 minus 1, if you see here 0 minus 1 is difference 1, borrow 1. So difference 1, borrow 1. Now go to the next step. 0 minus 1. What is 0 minus 1? Difference 1, borrow 1. So first I write the borrow here. I write the intermediate result, difference here 1. So 1 minus 0. 1 minus 0, see what is 1 minus 0? 1 minus 0 is 1. So write 1 here. Clear? Now go to the next one. 0 minus 1. Again 0 minus 1 is difference 1, borrow 1. So write difference 1. Write the intermediate result 1. So 1 minus 1. What is 1 minus 1? Difference is 0. So write 0. So fill the whole truth table using this subtraction truth table. After filling the truth table with subtraction truth table, now you need to use K-map to get the expression for D and to get the expression for B. So this is the K-map. How many inputs you have? X, Y, Z. So there are three inputs. So I need to go for three variable K-map. Three variable K-map, I get X and Y, Z. So plot the three variable K-map X bar X and write the combinations. Now first derive the equation for D. Now see in the D, what are the places where you have ones? Can you see this place you have 1. 1 means what? X bar, Y bar, Z. So go to X bar, go to Y bar and Z and place 1 here. Now see the next place where you have 1. So I have 1 in this position. So it is X bar, Y, Z bar. X bar, Y, Z bar. Write 1 here. Go down and check where you have 1 here in this position. That is X, Y bar, Z bar. So X, Y bar, Z bar. Go down. You have one more 1 here where it is X, Y, Z. So X, Y, Z. After plotting, check whether I can group. Since there is no possibility of grouping, it is only single group. Just write the terms. What is this term? X, Y bar, Z bar. What is this term? X bar, Y bar, Z. So I have written X bar, Y bar, Z. What is this term? X bar, Y, Z bar. X bar, Y, Z bar. What is this term? X, Y bar, Z bar. X, Y bar, Z bar. What is this term? X, Y, Z. So this is the equation for what? This is the equation for difference. Now I need to find the equation for borrow. Again do the K-map for borrow. So K-map for borrow. In borrow, how many ones you have? 1, 2, 3 and 4. What are the positions you have ones? X bar, Y bar, Z. So X bar, Y bar, Z. Do all the plotting. After completing the plotting of this 4 ones, What you need to do is you need to group. Now I can group it because these two are adjacent, so I make this a single group. These two numbers are adjacent, I will make it as a single group. These two are adjacent, I will make it as a single group. So I will get term 1, term 2, term 3. 3 terms, 1, 2, 3. Let us see first what is the equation, what is the term I get for this one. For this horizontal group, can you see for this two ones, what is common? X bar. You go up and see what is common for these two columns. Z is common. So it is X bar Z. Again, for these two cells, what is common for these two cells? X bar. What is vertically common for these two cells? Y. So it is X bar Y. Now come to this place. For these two cells, what is common for these two cells? These two ones common is Y and Z. So I have written Y and Z. So this is how I get the equation for what? Borrow. So I have derived equation for difference. I have derived equation for borrow. Now I need to draw the logic diagram. Now this is the logic diagram for difference and borrow. You know, 3 inputs X, Y, Z, and you know 2 outputs difference and borrow. So what is the equation? X bar, Y bar, Z. So I need to get X bar. When I get X bar, if I connect X to a NOT gate, I get X bar. So this is my X bar wire, this is my Y bar, and this is my Z bar. What is my first term? X bar, Y bar, Z. So this is my X bar, this is my Y bar, and this is my Z. Can you see? This is my Z. Put it in a AND gate. AND gate. I get my output as what? X bar, Y bar, Z. Connect that to which gate? OR gate. So to OR gate, sum gate. How many AND terms? 1, 2, 3, 4. So 1, 2, 3, 4. 4 AND gates are connected to a OR gate. That is my difference. Similarly, plot for what? For your borrow. First, what is the first thing? X bar, Z. So this is my X, this is my X bar. So from this wire X bar, and I need to take a wire, and from Z I need to take a wire. So this is X bar Z. Okay. Similarly, draw all the 3 AND terms are connected by OR. So 3 AND terms are connected by OR. So I get a borrow. This is how I have designed a full subtractor circuit. So we have constructed the equation for full subtractor using K-map and drawn the logic diagram. Thank you.